So far, we've learned the basics of running and managing Docker containers. Using pre-built images provided by Docker in the community is extremely useful, but we leverage the real power of Docker by building and sharing our own images. Our images could contain installations of specific third-party technologies, or they can contain our own applications. Packaging our versioned applications as Docker images is an extremely common practice. Packaging applications as Docker images makes your application extremely portable and can be done in a lot less time than it takes to bake a virtual machine image. As I just mentioned, packaging your own production applications is a major use case for building Docker images. So how does this work? Since Docker only runs on Linux, our container must only contain Linux libraries and binaries. The flavor of Linux we pick will dictate which libraries and package manager we will use. So first, we must pick a base image. Let's use Ubuntu. Our production application is written using the Python language, so we'll need that in our Docker image as well. So now we have an Ubuntu base with Python installed. Our application exposes an HTTP API, and so we'll need a Python-based web framework. We'll use Flask, which is a popular lightweight library for building HTTP services in Python. We now have the base infrastructure to run our application, so we just need to add our code. Remember, a Docker container operates in its own isolated view, as if it were its own machine. This means that it needs to explicitly define the ports that can be made available to the outside world. Flask apps default to port 5000, so this needs to be mapped to the Docker host. Docker images are built from layers. Layers are immutable, similar to a git commit. We don't change layers, we just create new ones. Like git commits, we can go back to any point and diverge if we like. We always reuse layers that don't change, and if we do diverge, we simply create new layers. We can name and tag layers at any level as well. For example, we could have tagged our Docker image after installing Python as something like Ubuntu Python, and use that as our starting image instead of building it each time. So what actually happens when we create images? Let's start over. Docker images are created by running containers, changing their state, and then saving the new state to disk. When the new state is saved, only the differences introduced in the new state are saved, which means that the state can be applied or reverted from the layer below. There's two ways to create Docker images. The first way is to run commands in a running container and commit the changes to an image layer. The preferred mechanism for building images is using a document known as the Docker file. Docker files list instructions to be performed on an image to produce new layers. Each layer in our example image corresponds to an instruction in a Docker file. Our bottom layer for this example is the base Ubuntu Docker image. This uses the from instruction in a Docker file. Our next layer is created by installing Python on our Ubuntu image. In a Docker file, this is done using the Docker run instruction. Now our image has Ubuntu and Python installed. The next thing we need is the Flask Python package. Once again, we can use the run instruction to install Flask via pip, Python's package manager. Next, we add our own source code from our machine to the image using the add instruction. We can then expose our HTTP API to the Docker host using the expose instruction. Our Docker file ends up looking something like this. We can then put our Docker file in source control and treat it like we do any other code that we write. We can version it, and we can even create automated builds to push and publish images when our Docker file changes. We can even use the entry point instruction to specify the default command to run so that the user need not know or care about the internals of the image.